Hello friends, welcome all of you. Today we see 12th Science Physics graphical questions on gravitation topic. So let's start today's video. Let's see the first objective. First objective is which of the following graph represents the motion of a planet about the sun? Let's see the option A, that means first graph. See the graph carefully. This one is the option A. Option B. Option C. And option D. So let's see the solution. The solution, it is the Kepler's law. We know that the Kepler's third law of the planetary motion, that is square of period of revolution of the planet around the sun, is directly proportional to the cube of semi-major axis of elliptical orbit. So here option C is correct. Direct variation of t square against the r cube. So let's see the next objective. Which one of the following graphs represent correctly the variation of the gravitational field F with distance small r from the center of a spherical shell of mass capital M and radius small a? So let's see the option A, that means first graph. Option B. Option C and option D. So let's see the solution of the second objective. Intensity will be 0 inside the spherical shell. So I is equals to 0 up to r is equal to small a, and I is inversely proportional to r square when r is greater than the small a. So here is option D is correct. Let's see the objective number 3. Assuming the earth to have a constant density, point out which of the following curves shows the variation of acceleration due to gravity from the center of the earth to the points far away from the surface of the earth. Let's see the option A, that means first graph. See the variation small g against small r. Next option B. Next option C and option D. So let's see the solution. Small g is equals to small r, that means acceleration due to gravity is equal to the small r means radius if the condition it is small r is less than capital R, and g, that means in acceleration due to gravity is inversely proportional to the r square. Condition it is the small r is greater than the capital R. So here option C is correct. Let's see the fourth objective. The curves for potential energy and kinetic energy of a two-particle system are shown in the figure. Let's see the figure, that means graph. At what points the system will be found? Option A is only at point capital D. Option B is only at point capital A. Option C is at point D and at point A. And option D is at the points A, B and C. Let's see the solution. The system will be bound at points where total energy is negative. In the given curves at point A, B and C, the potential energy is more than the kinetic energy. So option D is correct, that means at points A, B and C. So let's see the next objective. Suppose acceleration due to gravity at the Earth's surface is 10 meter per second square and at the surface of the Mars it is 4.0 meter per second square. A 60 kilogram passenger goes from the Earth to the Mars in a spaceship moving with a constant velocity. Neglect all other objects in the sky. Which part of the figure best represents the weight of the passenger as a function of the time? Let's see the graph clearly. Option A is capital A, option B is capital B, option C is capital C, and option D is capital D. So let's see the solution. Initially, the weight of the passenger is equals to 60 into the 10. So we have to get the final equation means final answer. It is a 600 Newton. And finally, the weight of the passenger it is 60 into the 4. That means 240 Newton. And during the flight in between some where its weight will be 0 because at that point gravitational pull of the earth and mass will be equal. So here option C is correct. So friends, today we stop here. In the next video we see the next topic, objective.
Hopefully you might have enjoyed the lecture. Then please do like the video and know your thoughts in comments. Please do share this video among your friends and don't forget to subscribe to our channel. After subscription you can press the bell icon to never miss the notification regarding our new videos. Thank you so much.